Hello, I'm Greg. Welcome to my channel, Midnight Oil Software. In this video, I'm going to show you how I made a simple typing game. And like most typing games, it's a race where the faster you type, the faster you run. In this case, you're a Triceratops racing against a Brontosaurus. I'm using a cute little Dinosaurs Pack I got off the asset store. I'll put a link in the description in case you'd want to use it in your projects. Now I'm going to show you basically how I implemented calculating the words per minute for your typing and how I correlated that to the dinosaur speed and to their animation. To start with, I'm going to show you the TypingController, which is a component that I put on my Race UI element here. The Race UI element basically displays the stats that you see up here on your screen, your words per minute, and how many mistakes you made. And it also displays this text here, which is what you need to type. But let's just jump into the class itself. And you can see it's a pretty simple C# script. I got some serialized fields here for the text box, your displayed text, your stat fields. I have a couple other diagnostic fields that I use for debugging. Sometimes I find it easier, instead of using log statements, if I just throw some UI elements up on the screen so I can see right away what's going on, that helps me debug things faster. And then I have the buttons to start the game and play again. I also want to point out that one of the ways I architected this game is I'm using the mediator pattern, which is a variation of the observer pattern, where you have a mediator that processes signals or events. And so anybody can fire an event on the signal bus, and then anybody else can subscribe to those events. And nobody cares where those events are coming from. So unlike the observer pattern where you're subscribing to specific events from a specific class that's triggering the events, in this case, you're just subscribing to them on the mediator, the signal bus, and you don't care who's firing those events. But let's get to the nitty-gritty here. I have a couple of hard-coded strings that's going to be the expected text that you need to type for the game. You've got basically just two of them. Probably if this was going to be a real full-fledged game, I'd have maybe some kind of a JSON file or something with a whole lot more text that you could choose from. And I tried to make this kid-friendly since it's sort of a kid's game. But to calculate the words per minute, I'm basically looking for input on the keyboard. And then when I get input, I check to see if the character that you typed matches the character we're expecting. So we know all the text that we're expecting, and I have an index into that list, which is the current character index. And so basically what I'm checking to see is if the expected character is the character at that index in the list that we want to type, right? And so maybe I should go up a little bit and start with the update method. So are we typing? If not, return. If we aren't typing and we hit a key, we jump down to that validate input. Otherwise, I want to check every second that we haven't typed. I want to recalculate our words per minute, because if you're sitting there not typing, your words per minute should be going down. I don't only want to calculate the words per minute when you're actually typing. So when we're typing and you type a character, I validate the input. So I get the string from the input for what you typed, and I only look at the first character, right? So the input character will be this one right here. And again, this is just for diagnostics purposes. You don't need to worry about it. So if the character you typed is not the one we're expecting, and we're not expecting a space, then we're going to treat that as a mistake. We're going to increment the number of mistakes, and we're going to calculate our words per minute. Now, the reason I'm doing this little piece of logic here is I want to make it a little bit forgiving. If somebody is reading that text that's up on the screen, they might not know they need to type the spaces. So I don't want to treat not typing the space as a mistake. I don't know. I'd like to hear your thoughts about that. But then after you've typed that character, I increment the current character index. And then I call calculate words per minute. And if you've typed all the text in that paragraph, which I think is highly unlikely, you'd have to type an insanely fast speed to do that. Then I want to set is typing to false because there's no longer anything to type. So then I also reset this little last time key press. So like I said, I want to, excuse me, every second that you're not typing, I want to calculate the words per minute. So that's what that little timer there is doing. All right, so in the calculate words per minute, we're going to get how many words we've typed. So I take the text that we've typed up to our current character index. I get the substring of that string, and I split it into words, and I do that by splitting it on spaces. And then however many words are in that array that I've just created, that's the number of words typed. And then I also calculate the elapsed time since we started typing, and I subtract that from the current time. And that's the time elapsed. So our words per minute, if we've been typing for at least a second, is going to be the words typed divided by the time elapsed times 60. All right, because time elapses in seconds. So multiply it by 60 to get the number of words typed per minute. All right, and then I'm also subtracting 1 for every mistake that you made. So if you typed 80 words a minute, but you made 5 mistakes, your words per minute will be 75. If you haven't been typing for at least a second, then we're just going to set that to 60. Now I'm doing a rolling average because I don't want the words per minute to fluctuate wildly. So I take your words per minute we just calculated, and I add it to this total words per minute, and I increment the words per minute count. And so we're going to basically, when we calculate our words per minute, we're going to divide the total words per minute by the words per minute count. And that's going to give us words per minute. So again, we can look up here at this expression body method property that's doing that equation right here. Right? Okay. So that's how we calculate our words per minute. After we've calculated our words per minute, we're going to fire a signal for words per minute changed. Now, I guess it's a good time now to talk about how I've kind of architected this using the mediator pattern. So we're going to look at our signals that we've defined. Let me do a little search here for signals. I have 4 signals. I have a word per minute change, a game state changed, a racer finished, and a countdown finished. So in this case, our TypingController is going to fire a word per minute change signal. So everybody that cares about the words per minute can respond to that. I'm also going to update our HUD. So this is where we display our stats, and it's also where we update our display text to highlight the characters you've already typed. So I'm essentially doing a substring for all that we've typed up to this point and wrapping it in an HTML tag with the color blue. Everything else, the remaining text, is going to be wrapped in an HTML tag for the color white. So that lets that highlight progress through the text as you type it. This is just for diagnostics, and these are our stats. This is where I show how many mistakes we made and our words per minute. All right, and that's using that expression body method. This is a format specifier for the integer display I want to display there. So that is our typing controller. Now, how does that affect the speed and the animation of our dinosaur? Well, our dinosaur basically has an animator and a nav mesh agent. So for the movement, I have a nav mesh surface on our terrain, and I have a FinishLine component that's going to represent the position that we want to run to. And so when we start racing, I set the nav mesh's agent destination to be the finish line. So he's going to run to the finish line. And then he's going to have a base speed for both the animation and for the nav mesh agent. And I'm going to calculate that speed based on the base words per minute for this dinosaur and the actual word per minute that we get in the word per minute change signal. So I am subscribing to 3 signals for the racer. We are subscribing to the words per minute change, game state change, and racer finished changed. I'm grabbing my animator and nav mesh agent component. And I'm also grabbing the finish line in the start method because I'm going to need them. And then I also, before the race starts, I want to display normally just an idle animation, but every so often I want to have the dinosaur prance. So there's 3 different animations that I will play when I prance. It will be prance, prance 2, and look around. These are animations that are provided with that Dinosaur pack, and we'll demonstrate them a little bit later. But basically, I want to randomly set a delay for when we're going to prance. It's going to be the current time plus a random interval of 2 to 10 seconds. And then I'm going to populate a collection of prances to play, and they're going to be ordered by a random value. So I'm going to have a list of those 3 prance animations, but the order is going to be random. And then every time I play a prance, I'm going to get one at random from that list. I'm going to remove it from the list, and then I'm going to play that animation and set the animation prance time, the next prance time, to be this value here. And I actually realized I could just get the first elements since I've already randomized the list. So let me go ahead and change that. It's like double random, doesn't need to be. And the reason I'm implementing it this way is I don't want the prances to repeat until they've each played at least once. So hopefully that all makes sense there. All right, so how does this work? How do we take our words per minute speed and relate that to the speed of the animation and the racer? So to understand that, we need to look at the word per minute changed signal handler. So if we're racing and we're the player, we're going to take the words per minute that was passed in on the signal and assign that to our words per minute variable. And then we're going to call calculate running speed. So where do we calculate running speed? That's right up here. First of all, we're going to make the nav mesh agent's movement speed based on the animation speed, because I want it to look like how fast he's running matches how fast he's moving forward. Hope that makes sense. So I calculate the animation speed by taking our base animation speed and multiplying that by a ratio that's calculated by the words per minute divided by 60. So the normal running speed of this dinosaur should be based on a 60 word per minute base. So I'm talking about the animation. The speed at which the animation runs should be based on a word per minute value of 60. So I'm going to calculate a ratio. So if you're running less than 60 words per minute, it's going to be a percentage below 100%. If you're running faster than 60 words per minute, it's going to be a percentage greater than 100%. So if you're doing 120 words per minute, we're going to double this animation speed. And by the way, I'll show you the animator controller I put together for this a little bit later, but I have a blend tree where I go from a walk animation to a run animation based on this animation speed here. So after I've calculated that animation speed, I calculate my move speed, which is what I'm going to assign to our nav mesh agent. So our animator speed property is going to be set to this value here, and our nav mesh agent speed is going to be set to this value here. All right, so basically I'm taking our base movement speed and I'm multiplying it by the ratio of our animation speed divided by the base animation speed. So all of that to try to make the run moving forward relative to how fast the animation is going, and both of those relative to your words per minute. So a whole lot of talking to explain what's going on there. In the start method, by the way, I just want to point out, I've grabbed all of these components, I've subscribed to these signals, but when we're destroyed, I want to make sure I unsubscribe to those signals. Always a very good practice. Now, we only care about the word per minute change signal if we're the player, because the dinosaur speed is hard-coded. Right now, I'm hard-coding it to a speed of 50 words per minute. So a really good idea for taking this game a step farther would be to have an adjustable skill level, so that the opponent's speed can be based on the skill level you're playing against. Because right now it's pretty easy to win if you can type faster than 50 words a minute. So on the game state changed handler, if we're racing, we start racing. In start racing, we set our words per minute to be our base words per minute. So if you're a opponent dinosaur, that's going to be what I've hard-coded to be 50 in the inspector. I think I'm setting the player's base to be 45. I'm going to set our initial position. We're going to call our initial running speed. We're going to set the nav mesh agent's destination to be the finish line. It's going to be our current position, except for on the x-axis, we're going to use the finish line's position. So you're going to run straight on your line to the finish line. And then we're going to set is racing to true. When the race is over, we're going to stop racing. We're going to set this to false. We're going to roll across the finish line. I think there's another animation I might want to try there instead, which is jump forward. So you kind of leap across the finish line. But right now I'm rolling across the finish line. I stop our nav mesh agent and I set our animator's speed to 0 so that that blend tree won't try to walk or run. And then I set our next prancing time so that the next time we start racing it, that'll be already set. All right, so I've covered calculating our running speed, got our words per minute changed on RacerFinished. So when the racer crosses the finish line, which is a game object that has a kinematic rigid body and a box collider that's set to is trigger. And on trigger enter, if it's a racer that crossed the finish line, I'm going to fire this RacerFinished signal and I'm going to pass in which racer crossed the finish line. This is important so that the race controller can know who finished first and know who won the race. And it's also important so that the racer can know, hey, was I the one that crossed the finish line? Because depending on whether or not I was the one that crossed the finish line, I'm going to do something different. So let's see how that works. On RacerFinished, we get the signal and we get the racer that finished. And by the way, I'm using a little bit of a lambda magic here. So when I define my subscription for that signal, I take the signal and I use a lambda to call on words per minute changed, passing in the value off that signal I care about. So in this case, I care about words per minute. In this case, I care about the game state. And in this case, I care about the racer. So those values will get passed in to that function when this signal is received. All right. So in on RacerFinished, if I'm not racing, I don't care. I've already finished. I'm not running. I don't care if somebody else finished the finish line. Now, if we are still racing and I'm the one who won, then I want to stop racing and return. Otherwise, if I'm not the one who won and I'm not the player, that means I'm the computer-controlled dinosaur, then I want to hurry up and run across the finish line so that the player isn't sitting there twiddling his thumbs waiting forever for the second place dinosaur to catch up. So he'll run across the finish line really quick because I set his words per minute to 1,000 and I recalculated his running speed. And you'll see that in action when I demonstrate the game. Prance, like I said, if I don't have any prances, I want to populate my prances array. I want to get the first one from the list. I want to set the trigger for that prance index. I want to remove it from the list and then set our next prance time. And then prance is called from update if we're not racing and we've elapsed our prance time, we call prance. So that's everything for the race controller. So we've done the typing controller, we've done the racer. Let's take a look at the RaceManager. This is where a lot of the logic for handling the race is controlled. So I have a few serialized fields here. I have the countdown. That's where we throw up our countdown numbers. I'm going to show you how I did that using those Toon numbers, which is another cool asset. And this is just basically a list of the countdown numbers, not the countdown, the finished numbers. So when you cross the finish line, you're either first or second. And I have a prefab for that. If you finish first, the number 1's going to run down in front of you and do a dance. If you're second place, the number 2 is going to run down in front of you and he's just going to sit there in an idle animation. So that's what these serialized fields are for. I am injecting the signal bus. So I am using the Zinject dependency injection for this and the mediator pattern, which I've already mentioned. So I am injecting the signal bus into this class so I can subscribe to these events. All right. So I also have a little property here, expression body method, that says whether or not we're racing, and we're racing if the game state is equal to GameState.racing. All right, and that is a Boolean that I use throughout this class. Game state, this is a property, and game state here is an enum. I've got not started, countdown, racing, and finished. So basically I have a getter and I have a setter, and I probably should make this a private setter because nobody should be setting that but me. So all I do is I assign the value and then I fire this signal, game state changed, and this is the game state we are changing to. So this way, anytime I change this property, that signal will fire. Anybody that cares about the game state will be notified. When we start, I set the game state to not started. I initialize a list of finished racers. This is just so I can keep track of everybody that's finished the race and know whether the game is over or not, right? Because if there's 2 racers and that list contains 2 entries, then I know 2 people cross the finish line, the race is over. And then this is where I would subscribe to the RacerFinished and the StartRace event. All right, update. If we are not racing, I just want to return, because the only thing I'm going to be doing in here is handling the enter key. Jason Story, who play tested this for me, said that if you have a keyboard-based game, you shouldn't make the player take his hands off the keyboard and click the mouse. So I have a start button, I have a play again button. You can click them with the mouse to play or to start again. But if you wanted to just keep your hands on the keyboard, I should just use the enter key. So what I do here is, if I'm not racing and the enter key was pressed, then based on the game state, I'm either going to call start countdown or I'm going to call play again. So that's the only purpose of my update method, is I handle the enter key. All right, so start countdown. By the way, I'm using the old Unity input system. If I was using the Unity input system, I would have an action map for these, and I wouldn't be polling it like this. All right, so start countdown. All I'm going to do is set the game state to countdown. That will fire the bus, signal bus event, and I'm going to display the countdown game object. I'll go over to countdown game object next. That's what throws up the countdown numbers, plays the countdown sound, and then will ultimately fire the countdown finished signal. The play again function simply reloads the scene. So the easiest way, if you want to replay a game, is just reload the scene. And I know I'm fine with this because all of my singleton objects are defined by their installers to be installed as singletons. So I don't have to worry about things getting instantiated more than once. Everything will be reset to their initial values, and you're just ready to play again. The start race function, I hide the countdown object or disable it. I get the racers that are in the game, and I want them whether they're active or not, and I don't care how they're sorted. And then I clear my finished racers array, and I set the game state to racing, which will fire the on game state changed signal. When I receive a racer finished signal, I want to determine what place this player finished in. So right now, initially, if nobody is finished, my finished racers collection is empty. So I am going to get my place numbers prefab at position 0. I'm going to instantiate it at the racer's position, but then I'm going to move it forward on the racer's forward axis by 5 units. So basically what I want to have happen, and this is a special prefab, by the way, that comes from that Toon numbers pack. If you use their number in place prefab, it will run to this position based on a certain distance that you specify in the inspector. So I'm saying I wanted to start 10 units away and run to this position. So there's a little placeholder that gets instantiated here, but then the number itself is going to, in my case, spawn 10 units above and then run down to that position and face the camera and do a little finish animation. So it's going to run, it's going to do an arrival animation and then end up with a finish animation. And I'll demonstrate that in great detail later. And I'm going to add that racer to our finished racers collection. So the next one to come through will get the second place prefab. And then if both racers have finished, I set the game state to finished, which is going to fire the game state changed event with the value of finished. So let's go ahead and take a look at our countdown. Going to go ahead and search for that. So the countdown has a transform for where I want this thing to be spawned. I just called it numbers. And I have the prefabs for the numbers that I'm going to spawn. There's 3, 2, and 1. And then I have a couple of audio clips. I want the countdown clip and then the starting bell clip. All right. So let's look at this signal bus here. I'm injecting that. That is so I can fire the countdown finished signal when the game is when the countdown is finished, so that the race controller knows when to start the race. All right. So first thing I want to do is grab my audio source off of this in Awake. So I set my countdown index to 2, so it's a 0 based array. So I'm going to go from 2, 1, 0 to get numbers 3, 2, 1. Hope that makes sense. So I'm instantiating the number prefab at that index. So the first, or the countdown number 3 is at position 2. Countdown number 2 is at position 1. Countdown number 1 is at position 0. I'm spawning them at the numbers position, which is just a game object I put on there for where I want it to spawn. I'm going to play the countdown clip. I'm going to wait for a second, and I'm going to decrement our countdown index and keep doing this until we've gotten to 0. Now, I do want to point out that my start method is an IEnumerator. It is a coroutine. So if you didn't know you could do this, your start method can be a coroutine. That way I don't have to execute a separate coroutine with start coroutine from in here. It will just work. When we're done with this loop, we play the starting bell and we set the countdown finish signal. We fire that. So that will cause the RaceManager to start the race, which everybody else can respond to. The finish line, I think I already covered that. It's just got a trigger collider and it fires the race finish signal. A couple other interesting things. I've got a music manager, which I have the signal bus injected in. I've got a few music clips. I got waiting music, racing music, victory music, and defeat music, which I'm not using. In start, I grab my audio source. I subscribe to the game state change signal, and I fired this thing, or I actually call this with not started, because I want to make sure I start playing the waiting music right away. That's because at the time when the initial game state change signal might have been fired by the race manager, I might not have been listening yet. So I just want to make sure that I start playing the waiting music right away. And the waiting music is on a loop. It will play indefinitely until the race starts, in which case I play racing music. And then when the race is over, I play victory music. Easy peasy. Similarly, I have, let me see if I can find here, audio manager. I have an audio manager with a cheer clip, starting bell clip, and applause clip. And it also gets the signal bus injected in. I grab my audio source. I subscribe to game state changed and race finished, or racer finished. So when I get a racer finished signal, I play the cheer clip. So I basically want people to cheer when a racer crosses the finish line. Now, when game state changes, if the race is starting, I play a cheer clip and the starting bell. And I should point out that there's a separate audio source on the audio manager that will play ambient crowd noise constantly for the entire game. So there's always some ambient crowd noise playing. But on top of that, I'm going to play a cheer and a starting bell when the race starts. And when a race, when the game is over, when the last player finishes the finish line, I'm going to play this applause clip, which is different from the cheer clip. All right, let's jump back out into Unity and look at some of the other interesting parts of this. We look at our RaceManager here. We've got our countdown object. This is the thing that plays the countdown numbers. We go 3, 2, 1. Those are basically just some of those Toon numbers, which I'll show you in a little bit. And they have an idle animation, but I just throw them up on a UI canvas. Right? So I'm going to go ahead and turn this on just so you can see it. I've got this UI canvas here, and I have this numbers rect transform, and I'm going to display that Toon number on that canvas. And now, even though it's a 3D object, I can render it in world space. Right? So this is a world space canvas, and I just positioned it so that when I play one of those numbers on there, it gets displayed on the canvas. So no matter what my camera view is, it would display where I want it to on here. And I also, on the prefab for those countdown numbers, I have this little shrink script that I wrote, and it's using do tween to basically scale all the way down to nothing over the course of a second, right? And then when it's complete, I'm just going to deactivate it. All right. So that's how I do the countdown numbers. I throw them up, they appear full screen, and then they shrink down to nothing. So 3, 2, 1, and I go ding. So that is the countdown. Let's jump back out into here and let's take a look at our music manager. You see I got those loops. We already looked at that. We already looked at the audio manager, the race manager, looked at that. I know we talked about the typing manager. So I don't think I really need to cover anything else there. We'll cover a little bit about how I made the track. The track is just using a bunch of pieces from an asset pack, Toon Racing. So Toon Racing has a ton of models. You've got tracks, you know, straight tracks, curved tracks, all kinds of different things like that. You've got different props. You've got lots of different cars. And let's actually take a look at the scenes in this pack. This will show you the cars. I don't use any cars in this game, but those are some cars you could use if you want to do a Toon racing game. And this pack has all of the props and tracks and stuff that you can use. I mean, this is just a fantastic pack with a ton of really cool assets. And they've also, you can see they've put in some post-processing with some fog and stuff. That looks pretty cool. You've got your stands. You know, I'm using these stands. I wonder if I shouldn't use these. I think these would look really cool. But anyway, I want to just throw something together quick and dirty, which is what I did. But that's how I made the track for the game. You can see there's our finish line. This is the track sections I used. Let's look at some of the other assets I'm using. I'm using the Toon numbers. Toon numbers is just a fantastic pack. Let's start off with this one here. I'm going to go ahead and hit play. So these guys are just too cute. They got all kind of cool animations. They've got support for motion. In fact, I'll show you that scene real quick. There's a Toon motion, or actually numbers navigation, I think is the one I want. So you can actually use a third-person controller here, and you can run around. You can move your camera, and you can run around. You can sprint. You can jump. I just think they're just too cute. Okay, so you get the idea. There's different way you can use these in math. They've got equation symbols and that sort of thing. I will show you this one here. This shows you how I use that number in position prefab so that you can see how the numbers run in from different positions and face the camera and end up with some final animation. So that's pretty cool. Let's go back. What else we got? We got the dinosaurs. Oh yes, of course. I've got to show you the dinosaurs. So I'll go into one of the sample scenes here. I'm only using 2 of the dinosaurs from this pack. I'm using the Triceratops and the Brontosaurus, but they've got all kind of different animations. You can make them walk, run, attack, tail attack, look around, jump, jump forward, prance, eat, sleep, wake up, swim, which I think is kind of cool, roll. Now I have mine roll across the finish line. I was thinking I might try having them jump forward across the finish line. I think that might be a good way to end the race. They can take hits and they can die. All right, so those are the dinosaurs. I will put links to all of these assets in the video description in case you want to use them in your projects. Full disclosure, these will be affiliate links, which means if you buy these assets using my links, I will get a commission. So thank you very much for that, if that's something that you choose to do. So I did want to show you the animator that I used for the dinosaurs. The animators that came with the dinosaurs didn't really work for me because all of the animations, first of all, like all the ones I'm using for Prance, were set to loop. But not only that, the animator controller didn't have the transitions. The way they seem to play their animations is they just say animator.play and then the name of the animation. Whereas I like to trigger my animations using a hashed integer from the trigger name. And so I'll show you how I do all that. If I go to my racers, and we'll just look at the Triceratops to begin with, you can see he's got an animator here, and I made my own animator controller, and I copied the animations for both dinosaurs that I wanted into my own animation folders. And that way I could turn their loop time off and all that kind of stuff. And like I said, I created my own animator controller. So if I double click that, it's very simple. Basically, I can go from any state to these prancing animations and to the roll animation, and they are based on triggers. So if you look at my parameters, I've got idle, look around, prance, prance to, and roll. And so if I say animator.set trigger idle, it will go to the idle animation. If I set trigger prance, it will go to the prancing animation, and so forth. So you can see I've got my trigger set up here, and this is the condition under which it will go to prance. And I also mentioned that I created a blend tree that will go from the walk animation to the run animation based on the value of the speed parameter. So walk, run are the 2 animations there. And then this is my blend tree where 0 to 1 will go walk, 1 to 2 will go run. So that's how I transition between the walk and run animation based on this speed parameter. So in my code, I set the animator speed, and then I can trigger different ones here if I want to. That is how I did that. For the numbers, let me go to my prefabs, and let's look at the first place prefab here. Oh, that's right. I'm using their place number in place prefab. So we take a look at that. That is, look at that crazy thing. But basically, it's got their model for the number 1 and with their animator controller and stuff. But more specifically, if we go down here and look at their prefabs, sorry, it's been a minute since I looked at this. You got this number and position prefab. And that's where you've got these different numbers here, and you can specify which number you want it to display. And then it's got that script there. And so when it spawns that number, that code that I showed you earlier that I modified, that's what handles, I actually made my own copy of that prefab. That's what actually handles triggering the animation. So let's look at first place and look at my script here. And yeah, so that's where I play the appropriate number based on what number I put in the inspector, and then I trigger the appropriate animations. And again, this is just a modification of their code that gave me. Sorry, that wasn't the greatest explanation because it had been a minute since I looked at that. But anyway, I really appreciate you watching this. If you found it useful and informative, do me a favor and click that like and subscribe button. It really does help with the YouTube algorithm. And I do want to get this content in front of as many people as possible. I will put links in the description for all the assets that I've used in this project. And if you want to use them and want to buy them, my affiliate links will get me a commission if you buy them using those links. Check out my Highland Panic game. It's a multiplayer, cross-platform, real-time game for the Apple iPhone, the Android, and for the PC on Steam. Links are in the description. I'm trying to think of what else I could tell you about. Be sure to tune into the Game Dev Show on Jason Wyman's channel on Friday at 12 o'clock Eastern Time. That's always a highlight of my week. And I think that about covers it. So, thanks so much for watching, and good luck on your game development journey.